Hey, all, welcome to the Common Good Podcast. Normally, I would have, our Vote Common Good podcast song playing. But I don't have it on my little sound deck, so you know what I'm doing? Playing funky music.
I like it.
All right.
I like it.
I do too.
Nice change up.
August 4th, it's a Thursday, talking with astrophysicist Paul Wallace, also professor, soon to be office tenant at an observatory. Is that news
Right
you
up
can
the hill
share
here.
with the with everybody?
Yeah, it's just, we've got the physics department here at the college has 5 offices, and the great resignation, that is sweeping the nation has affected our department. And we've had 2 of our one of them is already gone, and actually 3 of them. It's been a huge overturning of the baskets here in the physics department at the college. And basically my dream office has opened up and has been offered to me. So in the midst of the tumult and the overturning of baskets here, I've gotten the office of my dreams, and I'm going to be moving into it over the next week.
Excellent.
So next time I come to you, I'll come to you from the observatory. Maybe I'll walk around and give you a little tour.
Oh, we definitely will be taking a
with
tour.
my phone or something. Yeah.
Because among other things, that you are my only friend who does such and such. You're my only friend that offices in a observatory.
Yeah. Well, everybody needs one. I'm your friend.
You
I'm
and
yeah.
You and Kamala Harris doesn't
That's right.
doesn't the
Of
vice
the
president
Naval
live at the
Observatory.
Naval Observatory?
Yeah.
Yeah, I've heard that. Hey, how's the weather there, Paul? We like to chat about the weather at the start of things.
Yeah,
of
sure we
course.
do. Yeah, and you know what Annie Dillard said about the weather? Do you know what she said about the weather?
I don't even know
She
Annie.
said, she said there's only like 7 things in the world worth talking about, and the weather is one of them.
Do you know what the others are? Do you know the other?
No,
6?
I don't. I'd like to ask.
I bet it's
Dillard
astrophysics,
about
space,
Yeah.
goodness, faith, and the common good.
Yeah.
I bet those are.
I think space would be in there somewhere for Annie. Let's see. Right now it's overcast. It's not particularly hot. I mean, the heat's been. We had a really high week a couple of weeks ago. It got up into the high 90s.
Yeah.
Which is not too unusual for that to happen here briefly during the summer, but the humidity's been through the roof. So right now, I mean, we're having days that are topping out at about 90, which is really normal.
Yeah,
for August
you all.
here. But the humidity is really high, and we had lots of rain, and it's just really sticky. And my grass is so high in my yard now. I just can't. I go outside, left the house. I can't even look at it because it's just Normally by August in Georgia, the grass is getting kind of brown and it's kind of slowing down a little bit,
Yeah, starting to
patches
go
here
dormant.
and there, but
Yeah, burn
not
up.
this year. It's like tropical down here.
We are in for here in the Minneapolis area. One of those. My watch gives little editorial comments about the weather. I have an app. I don't know which app it is.
Yeah.
Something pops up on my watch and makes commentary about the weather and said, "Perfect summer day." Which has been like 20 of those this summer, it feels like, that I've seen those.
Wow,
so just,
good for you.
Mid
Was
80s,
it-
low 80s, lowish humidity, big, beautiful sky. Just
wow.
Hi, everybody, the weather says. Good morning. Welcome to the earth. We're glad
Well, there's a lot of folks who are not dealing with that, I tell you.
So, Paul, when a lot of us talk about the days getting longer or shorter, we just mean how much sunlight there is in the sky, right? So, that's a pretty simple thing. You say, I don't know why my camera's blurry today, too. I don't know. Everything is broken in my life.
Okay. Yeah, a little bit.
Really? Looks disastrous on my end.
There you go. Now you're in focus.
Yeah. Okay. If I just do
Come up close
the podcast like this, like we're at a coffee shop and we're just leaning in, talking with each other, and my face is gigantic. But apparently, this little news headline struck a chord with me. The shortest day in history, which is a great,
wow.
So the total headline for people that aren't reading it: shortest day in history: Earth completes fastest rotation ever on June 29th. An English lab says. No reason not to trust the English.
No way.
But I just love the idea that in our language and headlines and just casual talk, we like to say things like longest in history, shortest in history, as if we have measurements of all of history.
Right.
It's
Right.
such a human egocentric narrative, right? Like, uh, I don't
Well,
know, because to June 29th was the now recorded shortest day. Maybe, I don't know,
well,
a million years ago there was another
I
day, but
assure you that when this is a nice, this is one of those really nice headlines that grabs you. Shortest day in history. I mean, that's simple to understand, but that's really, I mean, depends on what kind of history you're talking about. If you're talking about since we began timing the Earth's rotation to the millisecond level, maybe so.
okay.
But I assure you that millions of years ago, the Earth rotated much more quickly than it does now.
So I wanted to
There,
chat about that today because I don't know when back in the 70s or 80s they sold atomic watches, and these were watches that I was told, like a lot of other people, this is a watch that doesn't keep track by like tightening a spring that's going to move at a certain rate. No, no, no. It is somehow connected to the atomic clock. And I was
yeah,
under the impression the atomic clock used the movement of atoms or something and
that's
kept
right.
track of precise time. Then come to find out, reading this article, they're like, yeah, and then every couple of years we just like skip a second on the atomic clock.
Yeah. Oh,
You know?
absolutely. Yeah.
So
There's
that
such
even
thing.
the atomic clock isn't accurate. That came as a
No, no.
surprise to me reading this story today. So tell us about this. The Earth's rotation, meaning its spin, not its journey around the sun, but its
Right.
spin
Right. It's
is
spin relative to, the background stars, basically.
moving at
Yeah.
different rate. Oh, its
It's moving at a
spin
different rate.
relative to the background
But
stars.
you have
Is
to
that
measure it. You have to measure it relative to something. So if you assume that the stars are essentially fixed, if you
okay?
assume that, then that's what the rotation is relative to. That's
Okay.
how we measure the
It,
Earth's rotation is against the backdrop of the stars. That's what we call the fixed point. The fixed points are the stars.
okay. And is that true? The stars are fixed, or are they also do they also have a move, a little
Oh no,
wobble, a little? They got a little
they're
something.
they're approximately fixed.
All right. Thank you. Because I was thinking, I don't know, the cosmos is expanding, everything is moving.
Yeah,
Okay, so
everything
in
moves.
so they triangulate, or they use
Yeah,
multiple stars, figure out
yeah.
the spin of the Earth. How do they know how fast the Earth is spinning at all? I mean, we're going to talk about the fact the Earth is slowing in its rotation
Yeah.
overall, but has apparently
Well,
fluctuations.
let's simplify it and say that you're standing at the equator, okay?
Okay.
And you look overhead and you see a star directly over your head.
Okay.
Doesn't matter what star it is. It's some nice little bright star directly over your head. The rotation rate is essentially measured by how long it takes for that star for you to rotate around the Earth to where that star is back over your head again. That's what I mean by rotation relative to the fixed stars. Rotation relative to the stars. So if you're standing on the equator, the star is right over your head. How long does it take for you to rotate once around the Earth? For the Earth to carry you around once and then return to that position with the star right over your head again. That
Okay.
is how we
So
measure
what
it.
you're doing with your fingers, which is I'm sure the right way to do it, because you are Paul Wallace, astrophysicist, soon to move into an observatory office. You have a
That's my
star.
entire title. Yeah.
Your fingers up top are a star.
Yep. Star.
Your hand below was, this is for the podcast people, was the Earth, and then
Yeah.
you
And then,
started rotating, pulling your hand away from you
right.
and back toward you. What I would have done, because I've seen a globe my entire life, was spun like left to right.
Right. This is my fist is the Earth.
Yes.
Okay. This is the North Pole right here. So the Earth is
Your fingers.
rotating this way. So this is half a day later. You're pointing straight down,
Okay.
then come back around.
So, why my brain's so broken?
I
So,
mean, just imagine that. Yeah. Go on.
no. You go on. Tell me what to imagine, because apparently I can't imagine the right thing here.
Um. No, I don't. It's not,
Paul is now
here,
searching his soon-to-be abandoned
okay.
shell of an office,
Okay.
and he has come up with a coffee mug.
Okay. Can you see this coffee mug here?
I do.
Okay. So this is the Earth's North Pole. We're looking down at the pole of the Earth.
Okay.
Okay. The pole is right in the middle of the cup here. This is you standing at the equator. Okay.
Okay.
Does that make sense so far?
Yes. So
Okay.
the handle is
So
me standing at the equator.
the handle is you standing at the equator. Okay. We're looking down at the North Pole of the Earth. Okay. And
From the
then what happens?
perspective of the star.
Yes. No. 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 We're looking at North Pole. The star is directly over your head. The star is right
Oh, I
here.
see. Okay.
Okay.
I'm an outside horizontal observer. All right.
Right. So what happens is the Earth rotates. The star stays put here.
Yep.
But the Earth rotates around once like this, carrying you with it.
Yep.
And then eventually it's going to end up pointing. You're going to end up pointing right back toward the star again, which is still sitting up here.
Okay.
That's one day. That's one sidereal, so-called sidereal day. That's one rotation of the Earth.
Okay, I got that. So
Okay.
I'm
That's
just
how we
wondering.
measure the rotation rate of the Earth. How long it takes for you to go around once
I
and
got it.
return so that the star is directly over your head again.
And that's this atomic measuring business that they're doing, and they're saying it took half a 1.5 milliseconds less to make that
Yes,
rotation
exactly.
on June 29th.
That's right. Which is
That-
actually a pretty big slice of time on, compared to how finely we can measure it.
Yeah, I mean that was just one of the spins. It's not like it, because also you mentioned this when we were chatting it before we came on, that the Earth's rotation is also slowing over time. Like,
Yeah, it's been slowing down. 400 million years ago,
okay,
there were about 400 days in a year. So the Earth rotated about 400 times every time it orbited the sun once. 400 million years ago, there were about 400 days per year.
any idea what's causing the
Yeah.
the
Oh, yeah,
overall
absolutely.
slow?
It's the moon.
It's the moon.
The moon is causing the Earth to
Of
slow
course it
down
is.
in its rotation, and that's why we have to add in leap seconds every now and again.
Why is the Earth slowing down the rotation over 400 million years? What's it doing?
Because the moon, well, I have to go back a few levels here. Basically,
Yes, you do.
have you heard of torque? You've heard of
Yeah.
the phrase torque before?
Mhm.
Well,
That's how much pressure is put on something to cause it to move or to
cause it to rotate.
rotate. Only rotate. Okay.
Yeah. It's rotation. It's a question of rotation.
Okay.
The moon is putting a very, well, for you and me on our scale, significant, but a slight torque is applying a torque to the Earth and very gently slowing it down over time. This happens all over the solar system. It's not like special to us. This is just one thing that happens because of Newtonian gravity, basically.
I see. So at some point the Earth will, will.
At some point the Earth will, the days will keep getting longer over long amounts of time. And we basically think of it this way. The days today are 1 millisecond longer than the days 100 years ago for this reason.
Wow. That seems like a lot. Is that a predictable? Well, I guess it's not a predictable amount because day by day, overall it's predictable, but it's like weather and climate.
This aspect of the Earth's rotation is pretty predictable.
Hey, does everybody on the planet have the same North Star? You hear this phrase literally. I was out in Lake Michigan last weekend and we looked up and saw the North Star and had a whole fabulous conversation about it with a telescope. But not everyone, because people are on the planet, I don't think you'll argue with this one, is something close to round.
Right.
So some people are on, if you're holding the planet, are on the top. Some people are over on the side.
Right.
Some people are 3/4 to the bottom.
Not everybody can see it. There's a range of latitudes in the southern hemisphere from which you can't see it, and those are approximately going to be something like, actually, anything south of the equator you can't see it.
You can't see it. Do people south of the equator have another version of the North Star? Like, are we just?
Nope. There's just they've got they don't have a south star. They've got a south blank spot.
What do they say in south of the hemisphere for their metaphorical analogy of staying on course? Like, if we say, what's your true North Star? What are they like? What's your imaginary North Star?
There's probably a particular pattern of stars that are close to the South Pole down there that they use. But it's just happenstance that we even have a North Star. It just worked out that way.
Oh, I see. There's nothing.
And,
Yeah,
and,
right, right.
and and not only that, but we're not always going to have one. Um,
There's just nothing consistent in this world. Now, how come we're not going to
no,
always have a North Star? It
because the
feels like
Earth's
it's the thing that people use as a metaphor of that thing that never changes, right? Like, what's your
no,
true
no,
North
it
Star?
all
What's the
changes,
thing you
baby.
can? Then the
It all
astrophysicist is like, oh,
changes.
this is, yeah,
It all
don't even
changes.
try.
If you take a top, okay,
Yeah.
and spin it,
Okay.
not only will it spin on its axis, but it'll also do something like this. Known as ever seen a
Yes.
top do something like that? Yes, called precision. And the Earth does that too.
It's got that. It's not a wobble. It's, I don't know what.
It's a wobble.
It is
It's
a
exactly
wobble?
what it is. It's a wobble. And so right now, if you sort of drew a line through that axis of the Earth, it would intersect at the North Star.
Okay.
But in a few thousand more years, it's going to point over this way. And so it's not going to point toward the North Star anymore. So it so happens that, as this axis of the Earth wobbles, it points towards different stars.
So I'm looking at this article. It says there are a multitude of reasons, and scientists aren't sure which one has caused this change in speeding up and shortest day and slower days of the rotation, the daily fluctuations, as opposed to just blaming it on the moon.
Yeah.
The Earth's rotational speed could be impacted by its inner or outer layers, oceans, the moon, or the climate.
I'm working on a climate one. I don't get that. All the rest of it checked off.
All that humidity, like, is that what it is?
I can't.
I can't imagine. I don't know what the climate is.
No, because
why the oceans? The oceans are sloshing water around, and it's slowing things up.
but if there's any large scale rearrangement of mass in the planet anywhere, it's going to change the rotation rate.
Wow.
Like you remember that big tsunami that happened a number of years ago over in the Indian Ocean, or the one up near Japan for that matter. Those were caused by shifts in the Earth's crust under the ocean, and there were perceptible changes in the Earth's rotation rate when that happened. Yeah.
Really?
Yeah. Because it rearranges the distribution of mass around the center of the Earth. And when that happens, it's just like a figure skater, right? Pulling her arms in, she speeds up faster and faster.
Yeah.
If there's any rearrangement of the Earth's mass on any sort of decent sized scale,
that is something else. Honestly, I mean that it just seems like the Earth is so big that, I don't know, one big movement of water shouldn't move that whole thing.
But we can measure it so precisely.
Oh, I see.
So if our measurement,
of course.
Yeah.
Okay.
Yeah.
I guess I was.
All it's nothing that you and I would even ever come close to perceiving.
Not even the most sensitive empath wouldn't be like, "Whoa, hold on a minute, hold on a second." I think I'm picking up something here.
One of those aura people that can see auras, one of those kind of people.
Yeah. We should probably have one of those folks on and be like, "Hey, when we slow down a 1.5 milliseconds on June 29th, did you think, boy, I could get a lot done today?" No, I guess they sped up. It was short. It was shorter. I just didn't have time. I couldn't.
Yeah, it just seemed to come and go so quickly. Yeah,
I wish I'd been late on something on the 29th of June, so I could have said, "Hey."
You could have blamed it. Yeah.
Well, the Earth slowed down. What am I going to do about it?
So
like you ran into traffic.
Yeah, right. Well, it sounds like even the scientists who measure this aren't quite sure what caused it.
Yeah, that's trippy.
There was no definite in the articles that I've read. There's no definite. They can't point their finger at any given specific thing.
And I think the article also said 20 of the last speeding up days. So the article says, the Earth has been experiencing many short days recently. In 2020, the Earth experienced the 28 shortest days in recorded history. And just last month, July 26th, was 1.5 milliseconds shorter than usual. So 28 of the shortest days in our recorded and shortest days history came in 2020. You know why? I think people, even the globe was like, Donald Trump is so intolerable. We just have to make this thing get over faster. Let's literally speed up time.
You know, I really when they talk about recorded history, it's like, okay, how many decades have we been able to measure the rotation rate of the Earth with this kind of precision?
Since the
That's what
1960s.
that's what they're calling recorded history. I'm not saying there's nothing to this. I'm just saying that when you hear that phrase recorded history, that doesn't mean since like the 10th millennium BC,
Good point. Good point.
That means within within an elderly person's lifetime, easily.
So the 1960s. Yeah.
Yeah, I mean,
did you say an elderly person's lifetime?
no, I'm talking about the last 100 years.
Yeah, I was gonna say, yeah. That
And
would include both of us as elderly people. Like, oh, an elderly person, like, oh yeah, like me and you, like the 1960s when this thing was.
no. I mean,
That's true. They've only been recording this
that's
for
really
60
generous.
plus years. Mm-hmm.
I mean, yeah, I mean, with this kind of precision. I mean, then of course they've been measuring the rotation rate of the Earth for thousands and thousands of years, but to this precision, where this sort of thing is even detectable, not
But it
that
does
long.
seem interesting that something has happened just in 2020 that caused 28 of the shortest recorded
Right. I'm
rotation
not saying
days
right.
in the last 60 years. But that happens in this kind of science, in science actions, that doesn't, like, things get clustered together. Like,
Yeah, if there's a root cause, there's got to
mhm.
be something causing this, maybe deep in the Earth's mantle or something. I
Well,
don't
I
know.
was going to say, I've been freaked out, I don't know, 15 years ago or something, when I learned that the Earth's magnetic
Hmm. Field.
situation flips.
Yeah.
And
Yeah.
they're like, oh no, we don't
Every
really
like
know how often.
250,000, approximately 4 times every million years,
Yeah.
something like that.
But we're due. Was the
Yeah,
story
we
as I
are.
heard? It's like we're
Yeah.
sneaking up on that. It's like the oil change. Sure,
The oil
sure,
change.
you get whatever number of miles, but 3,000 miles. But you're closing in on it. So
But
every time I hear this stuff, I'm telling you, I think the magnetic balance is about to flip, and then it just feels like it's chaos galore.
but
Lots of things aren't going to work right.
but see those switches, those changes in magnetic field, the polarity of the magnetic field, they probably
Mhm.
require 500 to 1,000 years to happen. I mean, it's not like you wake up on Tuesday morning and all of a sudden it's flipped. It'd be a long, gradual process, and basically it would be a process. What we
What?
would see is the Earth's magnetic field getting weaker. That's the way it would first appear. That it's just getting weaker over time,
Oh,
and that may be happening. I don't know, but over a lifetime, say over our lifetimes, Doug, we might see a slight but steady decrease in the strength of the field in the midst of a flip. That's what it would look like to us.
well, thank you for that. I was under the impression that it just happens, and that's that, and
Yeah.
it's made its flip. But you're saying that's not the case. Okay, well,
No, no. Like everything else, large
slightly
scale
better.
stuff. Very few things that are very physically large scale happen quickly.
Hmm.
Like
All right.
supernovas is one that happens quickly, but that's like the only one I can think of.
We have another story. I don't know if you're seeing this. I
I
don't know
don't
why
see it, but I
everything
saw
in
it a
my
second
world
ago.
everything in my world is broken today. I don't know why my
Mm,
computer. I don't know why my ones and zeros are not working the way they're supposed to. I just don't.
you got to keep those
Just
straight.
don't get it. All right, so the James Webb, our little superstar
Little.
stargazer, oh good Lord, is caught a glimpse of the most distant star in the universe. So
Ta-dam.
so okay, as you might imagine, and I sent to you maybe in a brief text. I don't know if you understood
Yep.
my angst about this article, but how do they know that it's the most distant star? It's the weakest amount of light. Is that the
No,
general?
no. Um, the way they know this is this. Um, you've heard the idea the universe is expanding.
I've heard this. Yes,
Yes, that's
mostly
not
from
news
you.
to you. Yeah. Okay. So it turns out that objects that are further away are moving away more quickly.
Okay.
So if you've got two objects, one of them twice as far away as the other,
Mm-hmm.
the one twice as far away will be moving away from you twice as fast.
Okay.
Yeah, that's more or less how it works. Okay. So all we need to do is figure out how fast something is moving away from us, and we can translate that into a distance.
Okay. That makes sense.
Okay. So the question is now not how far away is it? How do we know how far away it is? But how do we know how fast it's moving? That because once we know how fast it's moving away from us, we can tell how far away it is. So now we want to know how fast is it moving away from us, and we can tell that by taking the light from the star and breaking it into a rainbow, into a spectrum.
Okay.
And you calculate something known as the redshift. You might have heard that term before.
Yes, yes.
Yes. And the redshift tells you how fast it's moving away. And once you know how fast it's moving away, that translates into a distance.
Okay, so it seems like the impression from this article is that we have a pretty good idea about the edge of the universe. At least something I read in this article seemed to indicate that. Is that a right way to think about it? That we can know something about the
yes and no. What I would say is the edge of the observable universe, yes.
Okay.
But the edge of the universe, no.
Hmm.
There's no edge to the universe. Again, it's like being, remember that old Kevin Costner movie, Waterworld? That disastrous thing that came out back in the 80s or something.
I was going to say, I'm bored already
was,
just thinking about it.
Yeah. So the whole Earth was covered in water, like Noah's flood, right? The global flood.
Oh, that's what it was. Oh.
So if you're standing on a boat on such a planet, there is an edge to what you can see.
Okay.
But there's not an edge to the water anywhere.
I see. Okay, good.
Okay. So there's an edge to what we can see in the universe, but not to the universe itself.
So when they say, hey, this is just the star that we have some light from, and as far as we can tell, this is the furthest away of the stars that we can detect.
Right. It's the closest to, in the analogy of the boat, it's the closest to the horizon that we have found.
Do you happen to know, is there something about discovering this particular star that's the furthest away it's interesting for people? Have folks like you been waiting to hear this, or is this just
no? Well, it's like anything else. When you build a better telescope, a bigger telescope, you see further, you see more detail further away, and so we knew we'd find something older than what we found before, and this just happens to be it. But no, there's nothing like that I know of anyway. And I'm not in the midst of this research, so I don't know, but nothing that I know of this does not connect to some bigger theory necessarily. No.
I see.
No, it doesn't change the way we think about the universe necessarily. It more or less fits into, the theories that we have about the universe. It doesn't really challenge any old theories, but it's just an entertaining thing, fun thing to see.
Is that fun for scientists, or is it?
Oh yeah.
Study these. Okay.
Oh
so
yeah.
There, because the article indicates Hubble knew it was there, but now with James Webb, we really get to,
Oh yeah, right, right.
Is that what's exciting, or are there other? Because this is in the Futurism on Futurism's website. I mean, if you've got a site called Futurism, it seems like you're really leaning in,
Well, it's always nice to see, it's kind of like when I go birding. Think of it this way: when I go birding, and I see a bird, and I get a really quick picture of it, and I think, oh, that was a such and so. That was a yellow-rumped warbler, right? And I'm not sure about it, but I made a good guess based on what I could see in that brief second. Okay, but then I go home and I pull the picture up and I blow in and see it in more detail. Oh, I was right. My hunch was right. I was correct. I didn't have proof. It was more of just a really good guess. But now I know that I was right. It's kind of like that.
It's an awfully specific story. Did that happen to you recently? Did you catch it?
That happens to me. That happens to me all the time.
Oh, really?
Basically, it turns a hunch into certainty, and it's a good feeling. And that's what Webb did with this particular star.
Is that what birders do? Do all birders take pictures, or
No,
Oh,
no,
is that
I
a
do.
classification of birders? Like some of them are
Oh
out there, and you're
yeah,
like,
oh yeah,
oh, it's the camera
yeah.
birders versus the non-camera
There's
birders.
definitely a distinction. Yeah, I mean, the purists don't use cameras. They just go out there
Really?
with binoculars. Yeah, because they're birders. And then you've got who are sometimes referred to as the long lens people, right? Who go,
Gosh, I had no idea, but I just
yeah,
assumed like every other part of our world,
yeah,
it's
and then
put into categories.
and
The
you never
long
know with a long
lenses.
lens person if they're interested in the birds at all or if they're interested in just getting in pretty pictures.
In their camera.
Right.
Are you a long
And
lenser?
not really. My pictures are
Mm,
dreadful. I mean,
oh,
they're
I
really
see.
dreadful. Yeah, once every literally 200 shots, I get something worth putting on Twitter. But I usually do it to
On
help
Twitter,
me help me. Yeah, I know. Yeah,
there's a little pun. There's a little
I
pun
usually
that
take pictures.
the bird logo.
Yeah,
Social media,
yeah.
Twitter.
So I usually take pictures just to help me. I do it less now. When I was beginning, I did it a lot to help me identify
Hmm.
birds. That because I couldn't just look and know.
Is that
You know what I'm saying? I'm
totally?
getting better at that, so I don't take as many pictures now as I used to.
Is that part of the bias around long lensers? Is the other people are like, you shouldn't need that. You should know your bird. You should know your sound. You should know
No,
your wing
no,
flappers. And
I think I think it's a sense of like there's a purity to going out with a pair of binoculars only
I
and
see.
seeing it and remembering, you know what I'm saying? But when you try to grab it and you try to make a pretty picture,
Yeah,
but I think the simplest stereotype is that people with long lenses don't really know about birds. You know,
totally.
it's like they can
I
take really
love
good
it so
pictures,
much.
but then they take a great picture of this bird and they're like, I don't know what bird that is. It's just a pretty picture.
Oh, I see.
You know what I mean?
Yep, yep.
Um, but
Well,
uh,
it is such a just again a fascinating commentary on the human condition that pick your thing and people
that's
are going
right.
to divide into groups.
Yeah.
We talk a lot about faith and politics and stuff, and it's easy to think that in faith people are always dividing things up and which group is in and which group is out and who's going to
Yeah.
right, and you can blame religion, and then you can say politics is all this two-party business, and how come we can't just kind of all get along? Why do we have to? And then you just move
Neighborhoods.
through, just move through your things in your life, and somebody, he's like, oh no, those people, they water their lawn. That crowd down there, they're lawn waterers. They're not lawn water. Just there's no end to it.
There's no end to it.
It is. So it's almost as if we have to get good at just that and not wait for our politics or our religion or our
Yeah,
whatever
right.
topic we're into to not play by the rules that the rest of the human experience plays by. All
Yeah,
right, this
yeah.
this one was interesting. Um, they're talking about this glimmering antics of a cartwheel galaxy.
Yeah.
So incredible. Again, I just want to check with you. Do you know, is this photo that we're looking at on the live stream? If people are on the podcast only, it's spectacular. It looks like a big jellyfish, a
Yeah,
luminescent
it does.
jellyfish
Yeah.
in the sky.
Yeah.
Is this a artificially enhanced photo, or is this the kind of thing that the James Webb Telescope is giving us?
Oh, it's what it's giving us, but it's also, I mean, remember James Webb sees infrared light.
Okay.
Now, what if we look at this picture in visible light as you and I would see it with our naked eye, it would look similar. Has the same shape, has the same bright ring in the middle and the brighter ring out near the edge. It's got all that. It would look more or less the same, but some of the details in this picture uh, are of infrared light. I mean, it's all infrared light, but some of the details show up better in infrared light than they do in the visible. But to our eyes, it would look similar, not quite so red, for one thing.
I see. So this article reads, holy moly, I just lost the article, for crying out loud.
What I love about this picture are all the galaxies in the background. Those are
Yeah,
awesome.
yeah.
Yeah.
Say something about that while I find
Well,
this.
look at them. Everything you see in the background. And now, if you look to the right of the big galaxy of the cartwheel itself, you'll see a single star. with the
Uh-huh.
little spikes on it. That's a single star, but everything else in that picture in the background is a galaxy. And you can see
Incredible.
the one just to the right of the cartwheel, that little white one. It has nice little spiral arms to it over on the far right of the picture.
Yeah. Oh,
Yeah.
okay. So this article, and by the way, they call it the James Webb Space Telescope. So now I'm seeing this more often. The abbreviation JWST.
Mm-hmm.
So instead of having to write the James Webb, uh,
Yep.
is that
It,
what everyone should get used to? Is when you see a print
yeah,
story,
it's
see the
easy.
JWST?
Yeah, I don't know if they did it with Hubble too. I think that with Hubble they just called it Hubble's.
Hubble.
They
Yeah.
would just say Hubble. But in as an astronomer, I saw it written HST all the time.
Okay.
Is
Oh,
how
you
it was
did.
shortened.
Huh.
Yeah, all the time. So,
Oh,
but yeah, I
so
think
so for you all, JWST. Yeah,
it
it's
seems
not the
normal.
Jehovah's Witnesses' new outreach program.
The Jehovah's Witnesses Space Telescope. They've got their own telescope.
Points to the 144,000 people. Okay, so here's what the article says. The James Webb Space Telescope's new image of the Cartwheel Galaxy, which I guess is probably a nickname for the galaxy, that it's not really the technical astrophysicist
Right.
name, I'm guessing.
Right.
Located 500 million light years away in the Sculptor constellation,
Mm-hmm.
is the perfect example. That's down south from us.
Yeah, we can't see it from where you live or where I live.
Oh,
sorry to say.
Sort of our North Star to the people living in the southern hemisphere.
Yeah.
But it says it's the perfect example of a formation in motion. Previously, the Hubble in 1996, with its unique ring structure, which probably resulted from a high-speed collision between a large and small cluster 200 million years back, is already showing signs of growth. So this, what this Cartwheel Galaxy is showing is like the motion of the formation of what?
I'll tell you now. I'm not sure. First thing to know is galaxies are always colliding with each other. It's not unusual. We can look out in space and see many examples of galaxies in collision. Okay, first thing to know. In fact, our Milky Way will be involved in one in a couple billion years from now.
Do we have insurance for that? Do you know? Is that
it's pretty steep insurance? Yeah. So anyway, they collide regularly. Okay, it's not an uncommon thing, and that's what we're seeing here. And I don't know which one of those two galaxies on the left is responsible. Whether it's the lower bluish looking one I suspect it's the lower bluish looking one, but I'm not sure. Basically, one of those two galaxies has in the last couple 100 million years or so passed through the larger one. Okay, passed through it.
No, it's just. I know you say that as if a normal person can understand that. So remind us again what makes a galaxy a galaxy.
It's just a bunch of stars bound by gravity.
Bound by gravity, and they're moving. So when a galaxy collides with another galaxy, it means the stars and other items inside that gravitational structure, that's what collide into each other? Or do the forces are there some other forces, gravitational forces, that are colliding into each other?
Mostly stars don't collide with each other. You can have two galaxies more or less pass through each other, but so individual stars may not collide. In other words, so when we collide with the Andromeda galaxy 3 billion years from now, 2 billion years from now, whatever it's going to be, the sun it's almost certain that the sun will not interact with any others, will not collide with any other star. In fact, the solar system is probably going to survive just fine. But what happens is that stars disrupt one another because of gravity. They get deflected and they get pushed off in different directions.
I see.
Okay. And if you look at that small blue galaxy, you can sort of see there's sort of a tail going off to the left.
Yep.
Okay, that's what we call a tidal,
like
Tidal, tidal tail. Yeah, that's a tail of stars that's been strung off of it due to an interaction with another galaxy.
Oh, okay. So when
So
they see something like that, the explanation is, hey, this thing should be holding itself together because it's a solar system,
yeah,
and
yeah,
the gravity should be holding all that together. But we can see that there's this piece that's flipping out there,
right,
and the
right,
explanation is it must have interacted with some other
right.
gravitational force that
Exactly,
interrupted it,
exactly.
and that
So
means that they
right,
that's what's meant by galaxies colliding with each other, is that the
right, right,
gravitational pulls get all
right.
mixed up.
They disrupt each other and they lose their structure and kind of sometimes just fly all over the place. Um, yeah, but in this case, I believe it's probably that smaller blue galaxy on the left passed through the larger one.
Okay.
Okay, and it created a shock wave that ran out, sort of a circular shock wave that ran out from the center of that galaxy out to the edges.
Incredible.
And that's why the edges of that Cartwheel Galaxy are so bright. What you're seeing is the shock wave that was produced by one of those smaller galaxies passing through it. And if you could have watched it over time, you would see that bright ring moving outward from the center of the galaxy.
And what kind of time frame are we talking about for these things? What's the time frame that these
A couple
puppies are?
100 million years, maybe.
So they're overlapping each other for a long period of time. With a
Yeah,
collision, I guess,
yeah,
because the way I typically think about a collision would be, I don't know, a car or a person, and it feels very instantaneous, and then
right,
is over. This is like a passing by collision. That means something really different when you're talking about
right,
a
right.
galaxy.
Yeah, the whole, when we collide with Andromeda, from the time that you know the galaxies begin to be misshapen and disrupted to the time that it's all over could be a billion years.
Oh my gosh. Oh,
And
that's
by the way,
great.
maybe I'll
Um,
try to pull this up and show it to you and bring it on the podcast. There's some phenomenal computer simulations of what this collision is going to look like that have been done to give you a sense of what's going to happen to the Milky Way, in a little while. Just phenomenal.
so this is a good question from Anna. Anna is asking, will the Cartwheel Galaxy wheel continue to expand? So yeah, that's such an insightful question. That the edges of that light that we see in those images is so curious to me. But does
Yeah,
that
well,
all?
that is. I'm pretty sure that is the shock wave itself, and so that shock wave will find its way to the very edges of the galaxy and just disappear. It's not
Okay.
going. The galaxy is probably not going to continue to expand, get larger and larger and larger. It's more of just a wave traveling through the material, and that's going to find its
Yeah,
way to
the
the
article
edges and be
indicated
done.
that what the James Webb happened to catch here was the moment that all that energy or light was sort of moving away. It's not sitting there like a pixie spinner looking like that now, right? That this was a moment in time.
No, it looks like that now. I mean, that
I don't know
that
anything.
bright shock wave probably took 100 million years to make it from the center of the galaxy out to the edges.
Huh.
So it does look like that right now.
Well,
Yeah,
Paul
it does look like
Wallace,
that.
you're the best.
Thanks, man.
Hey, in 2 weeks, are we gonna see your new digs,
Yeah,
and we have a big telescope in
I'll
the background?
yeah, we got a big telescope. We got a planetarium. We got a few other fun little things. It's a great building.
You got a planetarium.
I
Yeah,
know
so
they're
we
great.
we need the walking tour of that. So
I took my 13-year-old to the planetarium and we laid down on the floor for about an hour yesterday and put on some music and let the stars go. It was great.
I don't even know what that means. You let the stars go. You mean
I
from
mean,
the planet?
we turned the stars on in the planetarium.
Oh, the
Projects the sky.
simulation.
Yeah, yeah, the simulation,
Huh.
and just laid there and enjoyed it for a while. It was awesome.
I've never been to a planetarium, so I think that's why I'm
You've
confused here.
never been? Oh my god! Oh gosh, you got one there, right? Somewhere in
I don't know.
Minneapolis.
Probably, yeah. I think
Oh
there's,
my, oh, you never been to a
it's
planetarium?
yeah. Yeah.
We got to change that.
It seems like it. It does seem a little unusual that
It's surprising.
it's a thing. It's a thing people do. But there's a lot of things some people do in their lives that other people never do. And when you ask them why, and they're like, I don't, I don't know. I've never. Isn't that funny?
No, I'm just surprised because you're such an astro buff. I thought you would
Totally.
have,
Well, me too. And like,
yeah,
that's what I'm saying. When you ask someone, why haven't you done it? And they just, I
yeah,
never did it. It's
yeah.
so funny. I don't
My brother
understand
never
all
saw
the
Star
things.
Wars. He was like 11 or 12 when that thing came out.
Yeah.
I don't know. I never saw it. I don't know.
Hey,
I know
it
what you mean.
hasn't bothered to go back and, shore
Yeah.
that one up.
Yep.
Well, thank you, buddy. Hey, thank you, Anna.
Sure.
Thank you, Jim. Thanks to all of you that are listening and commenting, and tell your friends. And if you're only watching on Facebook, great, glad to have you. Also, we're over on YouTube. We'd rather have you watch over there for all kinds of reasons, because the more you watch there, the more it helps our videos spread around over there. On Facebook and other places, they're good for a moment, and then they're gone, and nobody. They're just a vapor, just a glimpse, a shadow. But over there on YouTube, boy, those things they just give forever. They're just there until the galaxies collide.
That's
All right,
it.
Mr.
Hey, that'll
North
be a
Star.
while.
Thank you.
You're
Hey,
welcome.
we will talk to you all soon. Bye.